Okay, so today I'm going to teach you about Theorem of Pythagoras. Not that much complicated. I'm going to make sure that you fully understand it without having any doubts. So, something that you need to be aware of is that when it comes to Theorem of Pythagoras, we are mainly looking at a triangle, not just a triangle, but a special one called a right-angled triangle. Maybe so that you fully understand why this specific type of a triangle, let me just make a drawing there to say if you have this, definitely it is a triangle. Why? Because it has three sides and three angles. This is a side, this is a side, this is a side, an angle, an angle, and an angle. So that means a triangle, it is this type of a shape that has three sides and three angles. So the special type of a triangle that we are going to be looking at, it is this one that has a 90 degree there. You see, at that corner, it should be that box. This is the only thing that tells you that you are now dealing with a right-angled triangle, where one of the inside angles is equals to 90 degrees. So it doesn't matter if it is positioned like that, as long as it has this, then we know it is a right-angled triangle. Then if you have something which looks like this, ask yourself a question to say, is this a right-angled triangle? The answer should be yes or no. Maybe take a guess. Is this a right-angled triangle based on what I've explained up to this point? Nope. Definitely not a right-angled triangle. Why? Because it does not have that. It does not have that. Even though it looks like it is a right-angled triangle, as long as it does not have that, number one. Number two, as long as there was no statement which says consider a right-angled triangle below, then it is not. We just say it looks like. It is just a triangle which looks like it is a right-angled triangle. But the moment we have that, then we know it is a right-angled triangle. I hope that part makes sense. So maybe on the next page, let me just go deep and focus on a right-angled triangle. Something very much important. If you have that type of a triangle which is not a right-angled triangle, until we do that, then now it is a right-angled triangle. Obviously, we know that it has three sides and also it has three angles, and one of those angles it is equals to 90 degrees. That's where you have that corner there. So again, something that you should be aware of is that when it comes to the sides, side 1 we can refer to it as side 1, and again the second side we can refer to it as side number 2. But this longest side, it has a name. The longest side, it is called hypotenuse. The question now is, how are you going to know which side is hypotenuse? Hypotenuse is always the side which is facing that 90 degrees. So that means you might be having a right-angled triangle which is like that. What you know is that the side which is facing that 90 degrees, it is the longest side, and again it is called hypotenuse. So that means when you take side 1 in terms of its length and you compare it with the hypotenuse is always longer. When you compare it with that, it is always longer. So now, maybe for the last time, let me do this and say, doesn't really matter that much in terms of how the right angle triangle is positioned. What we know is that the moment it has this, then it's a right angle triangle, and most importantly, this is our hypotenuse, or the longest side, with this being side 1 and that being side 2. These other sides, they also have the names, but for today we will just leave it as side 1, side 2, and the longest one being hypotenuse. Maybe let me add an extra page there, so that we can now start looking into the calculations. So there is a formula that we use in order to calculate the sides of a right angle triangle. And the formula can be written in many ways, where, for example, they can say, maybe let's use h, which represents the hypotenuse. So that means that hypotenuse side squared should be equals to side 1 squared that you plus it with side 2 squared. Sometimes they can write this formula as r squared being equals to x squared plus y squared. It really doesn't matter that much in terms of how you write it. It all depends on what you are given and what you are trying to calculate. What we know is that that h represents the hypotenuse, which is equals to h squared equals side 1 squared plus side 2 squared. So let's maybe look at a right angled triangle and see the calculations involved. So it must have that for it to be a right angled triangle. Maybe they can say that point is A, this one is B, that one is C. It doesn't really matter that much. Maybe let's say this side it is 2, and then this side, let's say it is 3. So you can already see that you have two sides. The third side is unknown. That unknown side, is it the hypotenuse or is it just a leg or the side? It is the hypotenuse. Why? Because it is the side facing that 90-degree side. So now, in terms of the formula, you can create your own, whereby you say side AC. So that means your side AC being the hypotenuse, but you will say side AC squared is equals to, then you can choose any side in this case. You can start with side AB or side BC. Doesn't really matter that much, but what you need to make sure of is that it is the hypotenuse squared equals to adding those two sides each squaring. And then now let's say you decide to say it will be equals to AB squared, that you plus it with BC squared. So can you see, whether you use this formula or you use that formula, it doesn't really matter that much. So the x, you can substitute your 3. If you don't want to substitute the 3, you can still substitute that. What matters the most is that one side is there and then one side it is there. So now let's see. If we have to now continue with substitution, what is side AB? Definitely side AB, it is 2 plus, what is side BC? Definitely that is 3. So can you see, it makes no difference even if you had, let's say, 3 squared plus 2 squared. It's like you're having 2 plus 3, which is the same as 3 plus 2. I'm just giving you an example there to say it doesn't really matter that much in terms of which side you substitute and where. Okay, then it's fine. So what is 2 squared? That is 4. What is 3 squared? That is 9. So it looks like you have that plus that, which will be 13. So with you having 13 there, remember that 13 all along you've been calculating AC squared, AC squared, AC squared. So it is the AC squared which is equals to 13. So now you need to remove that squared. you will always put a square root. On your calculator, there should be a square root where you will know that now that squared has been removed. You see that AC squared, that 2 at the top has been removed, and then you just remain with, if you punch square root of 13 and it gives you square root of 13, then you just leave it as it is. You don't need to write it as a decimal. You just leave it in that format of a square root, unless if it was specified to say a final answer should be a decimal, maybe round it off to 2 decimal places. But if not, you just leave it as it is. So let me do another example real quick and say we have something of that nature there. And then maybe let's say this is 5, maybe this side it is 2. So the side that we need to look for, let's call it side X. So obviously, since you are given that side X, you can still say, okay, my R squared is equals to X squared plus Y squared. Which side is hypotenuse? It should be the one facing that 90 degrees. So that means that's where the 5 goes into the formula. And then that side X is the one that you are looking for. Plus, what is the Y side? It will be this one of 2. So you end up having 5 squared, which is 25, equals 2x squared. What is 2 squared? Definitely that is 4. So now you start solving just like I've taught you, where you need to make sure that numbers one side, letters one side. So you can take the 4 to the other side, where it becomes 25 minus 4 being equals 2x squared. That minus that, definitely it is 16 equals 2x squared. Now you need to remove that squared. So you will always follow this process, where now you have your square root of 16, that will definitely give you 4, and then that's how you've removed that squared. So that means x is equals to 4, and that is the end of it. So now I've just made calculations in 2 ways, where you calculate a side or where you calculate the hypotenuse. So let me just hold it here for now, and then I will do another example. Okay, so let me add an extra blank page there to try and do one more example. Okay, maybe this one, let's say you have something of that nature, and then you've got that, confirm it is a right angle triangle. And then let's say you have 1 meter, and then after you having 1 meter there, let's say here it is 3 meters, and then here they say you are having P. So please be aware that you've got your hypotenuse side being that one, and then you've got 2 sides. What you know is that you can use this formula which says r squared equals x squared, and that you plus it with y squared, and then easily substitute. You've got your 3 over there, and then your x value can still put 1 there, plus, and then your p squared. Then 3 squared, definitely that is 9, which is equals 2. What is 1 squared? It is just that, and then p squared, that's what you are looking for. 1 to the other side, 9 minus 1, definitely that will be 8, which will equals 2, definitely p squared. Then what you can do now is to square root both sides, so that you remove the square root on that other side of p. And then for 8, if you say square root of 8, you check what it gives you. If it gives you a decimal, do not write it as a decimal, it's fine, you can just leave it as square root of 8. Then remember, this looks like Desmond is my name, then rewrite it as my name is Desmond, where you start with a letter to say p is equals to square root of 8, and that is not the end of it until you say meters. Why? Because all the other sides were given to